Because usually once I teach unit 3 and we go over all these rules, everyone's like, hey, Miss Cole, what gives? Why did you make us do this whole limit as h goes to 0 formula in the last unit when we could have just been doing these rules the whole time? Well, I'm going to explain that to you. This was the first formula we did, and that was just how to find a derivative, so f prime of x. And then we had the alternate formula, which gave you the derivative at a specific point. So the reason that you still needed to know those is because this is how they show up on the AP exam. And what you have to do is notice the pattern that is being followed. So you don't want to do these as limit problems. You want to do them as derivative problems because, oh my goodness, like look at this. This is like a complete disaster. You do not want to do that as a limit. You want to notice that it is a derivative definition. It's going to be one or the other of these patterns. And you want to find the function that it is, take the derivative, and then plug in whatever value they're asking you for. I think there were like 10 or 12 questions on this worksheet. I just wrote out a few, so we won't do them all, just enough for you to like get the hang of it. For this first one, this part is representing the function. If you want to like match it up with this pattern here. And so our function is 2 times something cubed. So the function is 2x cubed. And so instead of doing this mess of a limit, you have a function that's actually really easy to take a derivative of. That derivative would be 6x squared. So it greatly simplifies the problem. And then you're going to plug in whatever number it is they're asking you to plug in. And for this one, it is a 5. You can see it right there in the pattern. So if we plug in 5, 5 squared is 25. 6 times 25 is 150. So it's a much easier way to do the problem than with that messy limit. So again, we don't have to do like every single one of these. I just wrote down a few, just enough for you guys to like get the hang of it. So for this one, does anyone want to give it a try? What would be the function that this pattern is showing us? Yeah, cool. You guys are just allowing Otis to be like your spokesperson for the class for today. All right, 4x cubed. And so somebody different, what is that derivative going to be? Good, cool, nice. 12x squared. And then the value that we want to plug in is given there in the pattern, that is 3. So we want to plug in 3 to the derivative. So 3 squared is 9 times 12 would be 108. And they weirdly used delta x for that one instead of h. It's the same thing. They just used a delta x instead of an h. Let's just have one more of those. This part is going to be the function. So for number 3, our function would be 5x cubed plus 8x. And so that derivative would be 15x squared plus 8. And then I'll ask you guys this one. What is the number that we want to plug into our derivative? 2. Nice, good. It is right there in the 2 plus h. So we're going to plug in 2. All right, so 2 squared is 4 times 15 would be 60, and then plus 8, so 68. Let me skip number 4 just for the sake of time here. Let me get down to number 10. What would the function be for this one? They use delta x again instead of h, but what would this function be? Yeah, good, cool. Sine of x. And so what is that derivative? Nice, cool. Cosine x. And then the value that we're plugging in is pi over 2. So let me draw that on our unit circle. Pi over 2 would be up here. That is the point 0, 1. We want to do cosine, which is the x part of the point. So that would be 0. So that's why you do still need to know the pattern. Now, there's a couple on here that use this pattern. You're going to do it the exact same way. It's just a different pattern to notice. So instead of like h approaching 0, you're going to have x approaching whatever number it is that you want. So like number 7 is an example like this one. So our function would be this first part. So x cubed plus x. And then that derivative would be 3x squared plus 1. And we would want to plug in 3. Its limit as x goes to 3. So 3 squared is 9, times 3 would be 27, plus 1 would be 28. And then here, I'll just do number 8 too, since we're here. This will be the last one. All right, so for this one, our function is this first part. So 2 over x. I'm going to write that as 2x to the negative 1. That's what 2 over x means. And then when I do the derivative, I'm going to multiply the negative 1 down. That'll make that negative 2. And then be careful. You need to subtract 1. So it's going to make that a negative 2. And then I can rewrite this as negative 2 over x squared. That's all your fun with negative exponents. And then for this one, we're going to plug in. Weirdly, they didn't give us a number. They just said t, plug in t. Okay, so if you plug in t for x, it's going to literally be that exact same thing except a t instead of an x. So negative 2 over t squared. But that was just good to do another example with the negative exponents.